sir.
ఈ లైన్స్ ఎవరమ్మా డ్రా చేశారు? ఓకే ఓకే. సో in today's session we are going to discuss about characteristics of the two-port network, and later I want to discuss about the conversion of H parameters into the remaining all parameters. So after completing the reciprocal condition and symmetric condition, if anyone are comfortable with the conversions like representation of the hybrid parameters in terms of the Z, in terms of Y, and in terms of ABCD, so you can left the issue, and if you want to listen, you can continue. I want to close the complete session, and from the tomorrow onwards we will discuss some problems. Okay, let we start our session. There are two types of characteristics for a two-port network, and they are reciprocal condition and symmetric condition. Whether the given two-port network is a reciprocal network, whether the given two-port network is a symmetric network or not. Now, what we will discuss about it, and how we decide by using the two-port network parameters. Two-port network parameters. So see, as you know about the reciprocity theorem, so reciprocity theorem states that the ratio between the voltage and current or excitation to the response is remains same, even though we interchange the positions of the excitation and response. So based on the reciprocal circuit okay, and at the output port I am connected to measure the current flow. I got some disturbance. Okay. Okay, so now we will discuss about the reciprocal condition. How we can decide whether the given two-port network is a reciprocal network or not. So as based on the information what we gain in the reciprocity theorem, same concept we can apply here also, right? Let's assume a two-port network having the terminals AB and CD. At first port I am giving the voltage. At the second port I am taking the ammeter. I want to measure the current flowing in the second port. I want to measure the current flowing in the second port, right? Right. Okay. So suppose if I am applying the voltage V1 at the first port and I am measuring the current I2 at the second port by using the ammeter, then what is the ratio between excitation to the response? That's nothing but the V1 divided by I2. V1 divided by I2. And this V1 and I2 ratio is calculated at V2 equal to 0. I think you accepted, because I am at the second port. At the second port I am taking the ammeter. To ammeter, we are connecting the ammeter means it is a short circuit. If it is a short circuit, then the voltage at the port equal to 0. At the second port, I am connecting the ammeter. Ammeter having the 0 internal resistance. 0 internal resistance means it is a short circuit. Once it is a short circuit, so V2 equal to 0, because second port voltage equal to 0. And we are calculating the ratio between excitation to the response, that is the V1 by I2 at V2 equal to 0. Okay. Now I am taking the same two-port network, but I am interchanging the positions of the excitation and response. See here, excitation is connected at the CD terminal, and I am taking the response at the AB terminal. Here, excitation and response are interchangeable. Now, again, I want to calculate the ratio between excitation to the response. I want to calculate the ratio between excitation to the response, right? Excitation to the response. So, what is the excitation now? What is the excitation now? Because I am giving the excitation at the CD terminal. I am giving the excitation at the CD terminal. So excitation nothing but voltage at the CD terminal. So CD nothing but it is a second port. CD nothing but it is a second port. So excitation to the response ratio, that is excitation is V2, whereas I am measuring the response, current response at the first port. That's the I1. But at see, I am connecting the ammeter at the first port. I am connecting the ammeter at the first port. If you connect the ammeter first port means ammeter having the zero relation. So first port voltage V1 equal to 0. V1 equal to 0. Right? Right. So now, as per the reciprocity condition, the ratio between excitation to the response will be remain same even though we interchange the positions of the both excitation and response. Even though we interchange the positions between the excitation and response. That means, as per the condition, the V1 divided by I2 must be equal to V1 divided by I2 must be equal to V2 divided by I1. Right? That is as per the reciprocity theorem or reciprocal condition. So what is the V1 by I2 at V2 equal to 0? That's nothing but the 1 by Y12, sorry, Y21, right? This is the 1 by Y21. Okay, Nama? Otherwise, do one thing. So V1 by I2 at V2 equal to 0. Can I write? Actually, what is the Y21? Y21, how we define Y21? Y21 equal to I2 by V1 at V2 equal to 0. Kadama? Right? Y21 is defined as I2 by V1 at V2 equal to 0. So it is a V1 by I2 at V2 equal to 0. That means this value can be rewritten as 1 divided by Y21. Right? Similarly, this also can be written as at V1 equal to 0, V2 by I1. So that's equal to actually Y12 equal to I1 by V2 at V1 equal to 0. Y12 can be defined as the ratio between I1 and V2 at V1 equal to 0. I1 by V2 at V1 equal to 0. So, but here it is at V1 equal to 0, this is the ratio V2 by I1. So we can write this one as Y by 1 by Y12. Y1, right? So as per the reciprocal condition, V1 by I2 must be equal to V2 by I1. So V1 by I2 nothing but 1 by Y12. That's equal to V2 by I1. That's equal to 1 by Y21. That's it. So 1 by Y21 equal to 1 by Y21 equal to 1 by Y12. So this can be again written as 1 by Y21 equal to Y12. Okay, Nama? So for any two-port network, if we have the admittance parameters, in that admittance parameters, if Y12 equal to Y21, then we can say that the given two-port network is a reciprocal network. That the given two-port network is a reciprocal network, right? So that is this complete derivation is based on the Y parameters we are discussing. Suppose for a given two-port network, if we have the Z parameters, for a given two-port network, if we have the Z parameters, then how we justify based on the Z parameters whether the given two-port network is a reciprocal network or not? How we decide? That is again conversion. So try to remember. So how we represent Y parameters in terms of the Z parameters? Go to the some Y parameters.
Z equal to 1 by Y.
Y parameters in terms of the Z parameters, right? So Y12 equal to minus Z12 by something, and Y21 equal to minus Z21 by something. If Y12 equal to Y21, then if we can make these two are equal, right? We can make these two are equal. If these two are equal, then we can write Z12 equal to Z21, right, Amma? As per the reciprocity condition, we concluded that if Y12 equal to Y21, then the given network can be said as a reciprocal network. If Y12 equal to Y21, so Y12 can be represented like this and Y21 represented like this. If these two are equal, both denominator terms will be cancelled, then Z12 equal to Z21, right? That means if we have the two-port network and we have the information about the Z parameters of the two-port network, so based on Z parameter information, we can conclude whether the given two-port network is a reciprocal network or not by using the Z parameters like Z21 equal to Z12. Understood, Amma? That means for a given two-port network, if we have the Z parameters, okay, And if you want to check whether the given two-port network is a reciprocal or not, then if the Z12 equal to Z21, then it is a reciprocal network. If it is not, then it is, we can say that it's not a reciprocal network, right? So that is in terms of the Z parameters. Similarly, we need to find suppose, because for every two-port network may not be all parameters are available. So we have to check for the remaining parameters also. We have to check for the remaining parameters also. Let's go for the Y parameters in terms of the ABCD parameters. Yeah, Y parameters in terms of the ABCD parameters, right? A two-port network is said to be reciprocal network if Y12 equal to Y21. Then you have to make these two are equal. If you make these two are equal, then denominators will be cancelled. Then we have BC minus AD equal to -1, or we can write AD minus BC equal to 1, right? So that is the reciprocal condition of a two-port network in terms of the ABCD parameters. So what is that one? So that condition is AD minus BC equal to 1, right? Similarly, check the Y parameters in terms of the hybrid parameters. Check ABC, Y parameters in terms of the hybrid parameters here. A two-port network is said to be a reciprocal or not based on the Y parameters. Like if Y12 equal to Y21, then we said that it is reciprocal. If Y12 equal to Y21, then make these two are equal. Then H11 and H11 will be cancelled. Then H21 equal to minus H12. H21 equal to minus H12. So that means, so if we have the hybrid parameter information of any two-port network, and if you want to justify whether the given two-port network is a reciprocal or not, then if H21 equal to minus H12, if this condition is satisfied, then we can say that the given two-port network is a reciprocal network, right? Okay, ma'am. So this is the complete summary about the checking the two-port network whether it is a reciprocal network or not, right? So if you have the Y parameter, then Y12 equal to Y21, then it is a reciprocal, otherwise it is not. If you have the Z parameter, Z1 equal to Z21, then it is a reciprocal network, otherwise it is not. If you have a ABCD parameter, if AD minus BC equal to 1, then it is a reciprocal network, otherwise it is not. If you have the hybrid parameters, if H21 equal to minus H12, then the network is a hybrid. Then the network is a reciprocal network, otherwise it is not a reciprocal network. So this is how we can use the information of the two-port network parameters to decide the given two-port network is a reciprocal network or not. Okay, Nama? So hope you understand what mean by the reciprocity or reciprocal, and what are the conditions for the reciprocal in terms of the two-port network parameters. Right. So later we will discuss about the second condition, that is the symmetric condition. Later we will discuss about the second condition called symmetric condition. Okay, symmetric condition we will discuss now, right? So now see the definition. A two-port network is symmetric if its ports can be interchanged without disturbing the values of the terminal voltage and current. Without changing terminal voltage and current. Try to understand that statement. A two-port network is symmetric if its ports can be interchanged. That means first port going to the second port connected to the first port, without disturbing the values of the terminal current and voltage. That means, see, we will discuss that also now. Right. See, let assume. So this is the one two-port network. Okay. At the first port, at the second port, I am connecting the ammeter. At the first port, I am giving some voltage V. Right? And I am measuring the current I. So let us assume, as I am giving the voltage V and measuring the current I. Now, so for voltage V, it gives the current I. Okay, na? If I apply voltage V at the first port, it gives the current I. So this is at port 1. That means we can write this one as V1, that is the port voltage at the port 1 equal to V, and I1 is the voltage at the port 1 equal to I. So we can write like that. Right? Now See, I am interchanging. See this statement. Interchanged. I am trying to interchange the voltage, and I want to now connect this voltage at the second port. I want to connect this voltage at the second port. Now I am connecting the voltage at the second port and connect the ammeter at the first port. Right? Suppose if I apply same voltage at the second port, if I apply same voltage V at the second port, then I expect same amount of current what happened in the previous case. I expect same amount of current what happened in the previous case. Then such type of circuits are called as a symmetric circuits. అర్థమవుతుందమ్మా? మనకు ఒక 2-port network ఉంది అనుకోండి. If we have a 2-port network, so the 2-port network has a 2 ports. One is the port 1, another is the port 2. At port 1, I am giving some voltage V, and that circuit draws the current I. Right, at port 1. Now what I am doing is, for the same circuit, I am not disturbing any elements. For the same 2-port network, now I am moving this voltage to this second port side. So I am moving the voltage to the second port side. Again, I am in the same voltage at the second port. If I got the same current, at the port 2, what I got at the port 1, then that circuit is said to be a symmetric circuit. So now it is at the port 2 now. So as it is at the port 2, now we can write this expression V2 equal to V and I2 equal to I. V2 equal to V and I2 equal to I. Only representation. V2 equal to V and I2 equal to I. Right. Now I want to calculate the ratio between this voltage and current. I want to calculate the ratio between current and voltage. Let us know. I want to calculate the ratio between current and voltage. So if I calculate the ratio between current and voltage, so I1 divided by, for the first circuit, I1 divided by V1 at I1 divided by V1 at second port is ammeter. That means ammeter means zero impedance. So that means short circuit. That means voltage is 0. So we can write this is as a Y11. Right? So Y11, that's equal to I1 by V1, I1 equal to I and V1 equal to V. So we can write this one as a I by V. Similarly, for the second case, for the second circuit, after moving the input voltage toward the second port side, then I want to take the ratio again. So ratio is I2 divided by V2 at, now the ammeter at the second port, sorry, first port. That means V1 equal to 0. Now we can write this as Y22, right? Y22, because Y22 is defined as ratio between current and voltage at the second port when the V1 equal to 0. So Y22, so that Y22 equal to V2 equal to V and I2 equal to I. That's equal to I by V. So if you observe these two equations, so finally we can conclude that Y11 equal to Y22. That means any circuit is said to be symmetric network. Any 2-port network is said to be a symmetric 2-port network if Y11 equal to Y22. If Y11 equal to Y22. Right, Amma? Whereas for the reciprocity, that is a Y12 equal to Y21. Whereas for the symmetrical condition, if we have the Y parameter information, if Y11 equal to Y22, then we said that the given 2-port network is a symmetric network. Right? No. Now, right. So now tell me, I think everyone is in online. My question is small analysis. Anyone can tell the answer. I have a 2-port network. And the 2-port network is satisfies both reciprocal and symmetrical condition. The 2-port have satisfies the both reciprocal and symmetrical condition. Okay. Now tell me how many maximum number of admittance parameters we need to compute to fill the admittance matrix. చూడమ్మా నేను క్వశ్చన్ కరెక్ట్గా వినండి. I have a one two-port network, and the two-port network is satisfies both reciprocal and symmetrical condition, right? Now, if I want the Y matrix, Y admittance matrix, that means Y11, Y12, Y21, Y22, ఈ మ్యాట్రిక్స్ ఫిల్ చేయాలి అనుకుంటే నేను ఎన్ని అడ్మిటెన్స్ పారామీటర్స్ క్యాలిక్యులేట్ చేయాలి? మాక్సిమం ఎన్ని అడ్మిటెన్స్ పారామీటర్స్ క్యాలిక్యులేట్ చేస్తే నేను ఆ మ్యాట్రిక్స్ ని ఫిల్ చేయగలను? 4. Anyone else?
Only 2, sir.
Inama?
2.
Yes, good. It is only 2. Because if you are able to calculate Y11, no need to calculate Y22. Because the two-port network satisfies the symmetrical condition, so Y22 equal to Y11, right? And if you calculate the Y12, no need to calculate the Y21. Because the given two-port network is reciprocal, so what is the value of Y12? Same value can be assigned to the Y21 also. So maximum 2 parameters you have to calculate that is sufficient to fill the Y matrix, admittance matrix of the given two-port network. If the two-port network satisfies the both symmetrical condition and reciprocal condition. Very good answer, Amma. Because this type of questions you may got in the competitive examination, that's why I'm asking. So only 2 parameters is sufficient. Maximum 2 parameters you can calculate, that is enough to fill the complete admittance matrix. Complete admittance matrix, right? Okay. Anyhow, so this is the symmetric condition in terms of the Y parameters. Again, we have to do for the remaining parameters also, because for every two-port network, there is not necessary we know the values of Y parameters. They may have the information about the Z parameters. They may have the information about the ABCD parameters. They may have the information about the H parameter. So we have to derive the condition for the symmetric condition, for the symmetric property in terms of all the parameters. So Y11 equal to Y22, it is already derived. Now use that transformation information. That means try to go back to the Y parameter in terms of the Z parameters. Go back to Y parameters in terms of the Z parameters, right? Y parameters in terms of the Z parameters. Right. So Y11 equal to Y22, right? Symmetric condition. So Y11 equal to Y22 ayindanu. That means this term equal to this one. Both denominators are same. So denominators will be cancelled. So finally what we have? Z11 equal to Z22. Right? Z11 equal to Z22. So if for a two-port network, if you have a Z parameter information, if Z11 equal to Z22, then we said that the given two-port network is a symmetrical network. Kavita, anyone have a doubt? Oh, some chart room, I will check. Okay. Right. Now, right. Similarly, we will check in terms of the ABCD parameters. Y in ABCD. So, if Y11 equal to Y22, then we said that the given two-port network is a symmetrical network. So, if Y11 equal to Y22, then D by B equal to A by B, then A equal to D. That means if for a given two-port network, if we know the transmission line parameters, and you want to check, you have to check whether the given two-port network is a symmetric network or not. Then, if A equal to D, then the given two-port network is said that it is a symmetric network. So that is in terms of the ABCD. So if Y11 equal to Y22, or Z11 equal to Z22, or A equal to D, so then we said that given two-port network is a symmetric network. Any of the 3 satisfied. And now move to the hybrid parameters also. This one. So Y11 equal to 1 by H11, and Y22 equal to Y11 equal to 1 by H11, and Y22 equal to H11 into H22 minus H12 into H21 divided by H11. So if a two-port network is said to be symmetric, if y11 equal to y22, that means 1 by h11 equal to h11 h22 minus h12 into h21 divided by h11. If these two are equal, then we said that it is a symmetric set. Then both denominators will be cancelled because the h11 this is also h11. So finally what we get, h11 equal into h22 minus h12 into h21, that's equal to 1, right? So all the conditions in terms of all the two-port network parameters are summarized in this slide. Yeah, here. If y11 equal to y22 or z11 equal to z22 or a equal to d or this condition satisfied, then we said that the given two-port network is a symmetric network. So the given two-port network is a symmetric network, right? So I think you understood what means by the condition, what means by the symmetric condition, and how we check whether the given two-port network is reciprocal or not in terms of the two-port network parameters. Also, I think you understood how we work with two-port network. Correct. Right? Now, try to solve this one. So in front of your screen, in front of you on the screen, you can see one problem, and please try to solve that problem. Please try to solve that problem based on what the information I provided till now. Till now means only in today's session. So ee roju session lo meeku cheppina reciprocity symmetrical condition concept base cheskoni you are able to solve this problem. You are able to solve this problem, right? So answers kuda meeku ichchanamma okkasari otherwise I will solve it. Right. The following measurements were made on a resistive two-port network, that is symmetric and reciprocal. Okay, Nama? So the given two-port network is a symmetric and reciprocal. Okay. Next, with port 2 open. With port 2 open. Port 2 open means what is zero? Ma? Port 2 open ante? With port 2 open ante then adham enti? Which port is? What parameter will be 0?
I2 equal to
good. I2
V1 equal to 0.
0. Okay, na? I2 equal to 0. With port 2 open, I2 equal to 0. And they provide the information that is V1 equal to 95 and I1 equal to 5. V1 equal to 95 and I1 equal to 5. Okay, Nama? Right? So tell me, I2 equal to 0 ante ఏ parameters మనం calculate చేయొచ్చు? They are asking Z parameters. Okay, na? Calculate the Z parameters of the given two-port network అడిగారు కదమ్మా. So
Z11, Z21.
Right. So ఇక్కడ చూడండమ్మా, I2 equal to 0 and I have the information of V1 and I1. So I2 0 అయ్యుండి V1 I1 ఇన్ఫర్మేషన్ మనకి అవైలబుల్ ఉంటే ఏ పారామీటర్ మనం క్యాలిక్యులేట్ చేయగలము? Forget about the complete problem, just concentrate here. This I2 equal to 0 and V1 equal to 95, I1 equal to 5. So which parameter we are able to calculate by using this information?
Z11, Z21.
No. Only Z11. It's okay.
Only
Z11. I am okay. With this information, what we have right now. Okay, with this information we can calculate.
Z11 and Z21.
So Z11 equal to V1 divided by I1, that's equal to 95 by 5, that's equal to 90. Okay, Amma? Okay, na?